Correlation. The correlation coefficient, R, measures the strength and direction of the linear relationship between two quantitative variables. The formula to find the correlation coefficient is R is equal to 1 divided by n minus 1 times the sum of all the x's minus their mean divided by their standard deviation times the y's minus their mean divided by the standard deviation. The point x bar y bar represents the mean of x and the mean of y. The values s sub x and s sub y are the individual standard deviations of x and y respectively. And n is the number of data pieces. Some facts about correlation. Positive R values indicate a positive association, and negative R values indicate a negative association between the variables. The value of R is always between -1 and +1. The closer the absolute value of R is to 1, the stronger the association. If R equals 1 or -1 exactly, then every point fits on the same line. A weak association will have an R value closer to 0. Correlation is strongly influenced by outliers. So let's return to our example for the cost of properties related to the spaces they are from Go in a Monopoly game. Here is the scatter plot of the data. Now let's find the correlation for this data and see if it confirms the fact that this is a strong linear relationship. I'm going to quit out of this mode. Now before we do the correlation, it's best that you have your diagnostics turned on. In order to turn on your diagnostics, you're going to go Second, Catalog, and scroll down to the D's. Select Diagnostic On by making sure your arrow's there and choosing Enter. Now what we're going to do is choose Stat, Calculate. Now under the Calculate menu we have lots of different choices. What we're going to choose here, linear regression A plus BX. So that's number 8 on the menu. Indicate your X list and Y list. If we want to store the regression equation, which we'll talk about in the next section, we'll do that there. But let's just do Calculate. And you can see that we get this value of R to be 0.87797. This is pretty close to 1, and it's a positive number. So it does confirm that we have a strong linear relationship between the spaces from Go in a Monopoly game and the cost of the property.